In section 7.6, we're going to look at properties of linear systems. Now, let's stop and think about the different possibilities of two lines being drawn on a graph. The first case is I could have line 1, and I could have line 2. And if you notice, these two lines have one meeting point. They cross once. If you notice, the slope of the red line is nowhere equal to the slope of the blue line, so we could say that M1 does not equal M2. Again, this is line 2, and this is line 1. So if two lines in a system have different slopes, they're going to meet one time, and we call these intersecting lines. And they have one solution, meaning they only cross once. Now, another possibility is we could have line 1 like that, and we could have line 2 like that, and these two lines are parallel. Okay, they have the same slope, so M1 equals M2, but the y-intercepts are different. As you can see, the y-intercept of the red line is up there, and the y-intercept of the blue line is down there. So the y-intercepts are not equal, but the slopes are, and we call these lines parallel. They have no solutions because they never cross. Finally, the last case is I have line 1. Whoops. The last case is I have line 1 like that, and line 2 is right on top of line 1. So in this case, I have M1 equals M2, and B1 equals B2, and these are the same lines, so we call these lines coincident. And these ones have an infinite number of solutions because the lines are touching in infinite number of places. So we're going to reference these three graphs as we move forward throughout this lesson. Now, how can we determine the number of solutions in a linear system without solving the system? Well, we're going to use the information we just generated on the previous page. So let's determine the number of solutions of this system. So what we're going to do is we're going to put each system in the form, or each line in the form y equals mx plus b. So my first line is going to be y equals negative x plus 3. So my slope is negative 1, and my y-intercept is 3. For my second line, I'm going to have negative y. I'm going to add the 2x to the other side, and then I'm going to divide each term by negative 1. Notice my slope is negative 2, b is equal to 2. We always start by looking at the slopes. If the slopes are different, we know we have intersecting lines, we have one solution. Done. Okay, so as soon as the slopes are different, we know we only have one solution, and we can say that these lines are intersecting. Okay, let's take a look at this one. So I'm going to isolate y here again. So 6y is going to be negative 4x minus 10. If I divide everything by 6, and then if I reduce this, I get negative 2 over 3x minus 5 over 3. So my slope is negative 2/3. My y-intercept is negative 5 over 3. Now in my second equation, I'm going to isolate negative 3y by adding 2x to the other side. And now I'm going to divide by negative 3. So I get negative 2/3 x minus 5 over 3. So again, my slope is negative 2/3, and my y-intercept is negative 5 over 3. So again, to compare, first of all, look at the slopes. The slopes are the same, so they can't be intersecting. They can either be coincidence or parallel. And so now we're going to look at the y-intercept. The y-intercepts are the same, so therefore these are the same line, and therefore they're coincident, and they're an infinite number of solutions. All right. I encourage you to pause the video and give this one a try. Okay, hopefully you've had a chance to try this one. So again, let's isolate y here, first of all, by isolating the negative 4y. So I'll subtract the 2x over, and now I'm going to divide by negative 4. So my equation is going to be 1/2 x plus 1/4. So my slope is 1/2, and my y-intercept is 1/4. In my second line, I'll isolate the negative 6y by subtracting the 3x over. And then I'm going to divide by negative 6. And I'm going to get y equals positive 1/2 x minus 1/3. So my slope is 1/2. My y-intercept is negative 1/3. So now we compare the slopes. They're the same. So they can't be intersecting. They're either coincident or parallel. And since my y-intercepts are different, that means they're parallel lines. Parallel lines have no solutions. So simply by comparing the slopes and y-intercepts, you can see we can determine how many solutions a linear system has. In our next example, we're given the equation negative 6x plus y is equal to 3, and we want to write another linear equation that will form a linear system with exactly one solution. So let's first of all get this equation in the form y equals mx plus b. So we know our slope is 6 and our y-intercept is 3. So in part A, we want to form a linear system with this line and another line that will have one solution. So if you recall, for a linear system to have one solution, our two lines have to have different slopes. So I just write y equals 3x minus 4. That slope is 3, that slope is 6. They're different. They're going to have one solution. Okay, in part B, I want to have a linear system with 6x plus 3 and another equation that have no solutions. So in that particular case, our slopes have to be the same, but our y-intercepts have to be different. So this equation here, 6x minus 1, and the original 6x plus 3, those would have no solution. For part C, to find infinite number of solutions, I'm just going to take my original equation and times everything by 2. And now I have a linear system, this guy here and this guy here, that we will have infinite number of solutions because technically they're the exact same line. So that example was pretty easy. Again, there's more than one possible solution for these, but this is one possible case of solutions. Okay, in our last example, we're asked to determine the value of k. So we're looking for a missing coefficient in this line so that our system has no solutions. So remember, if our system have no solutions, our slopes are going to be equal, but the y-intercepts are going to have to be different. So let's get each line in the form y equals mx plus b. So in our first line, I'm going to subtract the 4x to the other side. And then I'm going to divide by negative 30. So y is going to equal positive 2 over 15x minus 2 over 3. So I know my slope here is 2 over 15, and my y-intercept is negative 2 over 3. In my second equation, I'm going to again isolate y by subtracting the 3x over. And now I'm going to divide by negative k. So now I get y equals 3 over kx minus 60 over k. So my slope here is going to be 3 over k, and my y-intercept is negative 60 over k. So now, if my slopes are the same, because again, to have no solutions, my slopes have to be the same. So that means I'm going to take this and make it equal to that. So therefore, I'm going to say that 2 over 15 has to equal 3 over k. 2 over 15 has to equal 3 over k. And if I cross multiply, I get 2k is going to equal 45. So k will be 45 over 2. So if k is 45 over 2, I know that my two lines will have the same slope. So let's now verify if k is 45 over 2, that my y-intercepts will be different. So I know that the y-intercept of my first line was negative 2/3. We found that right here. And if I take my y-intercept of my second line, which was negative 60 over k, and if I substitute in 45 over 2 for k, I'm going to get, if I multiply by the reciprocal, I'm going to get negative 60 times 2 over 45, which will be negative 120 over 45. And if I reduce negative 120 divided by 45, I'm going to get negative 8 over 3. So again, these y-intercepts are different, but the slopes are the same. So the value of k that will make this linear system have no solutions is when k is 45 over 2. Okay, that ends section 7.6. So there's your assignment on page 449. Give those a try, and again, check the answers on the website if you have any problems.